Hi, welcome to PhyLab application. In this tutorial, we will be looking at how to perform convex mirror experiment in our PhyLab application. Start the simulator of convex lens and then the aim will be displayed as a dialog box. Close the dialog box and we will start with distance object method. So lens is placed to point a distance object and move the screen so that the object is very clear on the screen. So then click on the observation button and enter the distance between the lens and the screen. It is 15.5. So that is the focal length by using distance object method. Next one is UV method. The first one is keep the lens 20 centimeters from the object. Let's drag the lens and keep it at 20 centimeters and then click on observation button, enter 20 centimeters. Now drag the screen so that the clear image appears on the screen. Once the clear image appears, click the observation button and enter the details. And next we will go with lens at 25 centimeters from the object. Enter the 25 centimeters and then again move the screen so that clear image displays. So once the clear image displays, click on the observation button and enter the values. Like this, we need to repeat the experiment for 35, 30, 35, 40, 45 and so on. So I will be speeding up the video here. So 35 is done. Next 40 is done. So once all are done, we will go into conjugate foci method or lens displacement method. Here we will fix the distance between the screen and the object at 70 centimeters and then we will move the lens first a distance where we can see the image clearly. Here we can see the image clearly. Click on the observation button and then enter the distance between the lens and the object. It is 23 centimeters. Again move the object closer to the screen and you will see one place where image is very clear. Now note the distance as 47 centimeters. And we need to repeat the experiment for different distances, like increasing 5 centimeters every time. 70, 75, 80, 85, 90. So I will be speeding up the video here so that you can see clearly. We can save some time here. Okay. Now 75 is done and then 80 is done. So on completion of all values, we will be greeted with calculations page. The final reading is going on. So now we will be greeted with calculations page. So we'll perform all the calculations, like we will calculate the 1 by u value, 1 by v value and then focal length for different distances. And finally we will measure the mean focal length. So the mean focal length is sum of all the focal lengths and divided by 5. And next one is we will draw graphs. First one is UV graph. So by using mouse, we can actually control the graph. Either we can scroll to zoom in and zoom out, and then click on the graph paper and then move the mouse. So after that we have pointer mode and then line mode. Whenever you want to place a pointer, you should be in the pointer mode. Click on the pointer mode and place the dots wherever you want. Yep. Next one is 30. It is 31.50. Next 35, 27.50. You can observe whenever I want to move the graph paper, I am exiting the dot mode, like clicking on the dot mode again. So now all dots has been placed. Now I will enter into line mode. So I can use the undo button to undo the previous any mistake if I did, and then I am zooming in a bit to attach all the values. Just I'm extending the graph. Now from 0 I will be drawing a 45-degree line here. So from the intersection point, I will be drawing an axis parallel to x-axis which intersects y-axis, and line which is parallel to y which intersect x. So after drawing these two lines, I will note down the values to calculate the focal length by using UV graph method. So 31 plus 31 divided by 4 is 15.5. So once you are done, submit the graph. That's it. So here we can add 15.5. And the next one is 1 by U and 1 by V graph. So here also we will do the same operations. Like first we will plot all the dots and then we will join the dots. For 3.3 it is 3.18. 18 means almost equal to 2. Next one 2.86 is 3.64. See, I am exiting the dot mode to move the graph paper. And then 4, 2.5 is to 4. So I will be joining all the dots as close as possible and then extending the line so that it intersects with x-axis. And then again I am drawing a new line, overwriting the over line so that it can intersect with y-axis. Now I will note down the values where actually it is intersecting with x-axis. It is 6.6, and then the total value multiplied by 2 is 15.26. After that I will submit and then calculate 15.26 here. Now this is the value we got from 1 by U 1 by V graph, and after that conjugate foci method. So here we will do all the calculations. We got already D1 and D2, and we will get the absolute value from D1 and D2. It should be positive value. It doesn't matter which one you detect from other one, we will take the absolute value. It should be positive one. And after we got everything, we will calculate the focal values. After getting all the focal values for 5 observations, we will calculate the average value, like summing all the 5 values and divided by 5, because we have 5 observations. So we got 15.256. So after you've done all the calculations, just click on the submit button, and then it will validate all your data with the actual focal length of the lens, and then if it is successful, it will upload your data to cloud. So once it's successfully updated to cloud, you will be prompted with a dialog box with congratulations. Then we will close the dialog box. So we will close the dialog box. And then again we will come to home page. Here we will again try to open the Convex Lens. Now you can see there is a download button. Click on that. It will prepare a PDF report for you and it will download it. So this will contain all your observations and graphs so that you can print it out and you can show to your lecturer. Zoom in a bit. So here you can see all the values have been calculated and it is presented in a neatly PDF manner. So thank you.